So in last lecture, we have discussed the reactions of fatty acid. What will be the reactions of fatty acid? Will within a fraction of second we will revise them. Fatty acid undergo oxidation reaction, halogenation reaction, hydrogenation reaction, saponification reaction, and esterification reaction. So these many reactions, these are very important in terms of exam point of view. We have discussed them in detail in yesterday's lecture. Now, today we are going to discuss reactions of lipid. Now, what is lipid? These are actually esters of fatty acid. Means fatty acids are derived from the lipid. We have discussed this during the classification of lipid. लिपिडच्या क्लासिफिकेशनच्या derived lipid class मध्ये we have discussed fatty acid. And our syllabus or we are interested in the reactions of fatty acid. But we are also going to discuss some of the properties of lipid also. Now, simple lipid or triglycerides. Simple lipid means those lipid which are actually only esters of fatty acid. They will not contain any presence of prosthetic group in their structure. So they are actually triglycerides or fats and oils. So these are from the glycerol and fatty acid. After the hydrolysis of these triglycerides means what? One glycerol molecule will form a ester bond with 3 molecules of fatty acid. So this triglycerol upon hydrolysis give only glycerol and fatty acid. Same or different type of fatty acids. So they are going to produce either same type of fatty acids or different type of fatty acids. That means triglyceride formation vary whether they have used or in their structure whether same type of fatty acid or different type of fatty acid is there. So upon hydrolysis, those triglycerides will form glycerol, one molecule of glycerol and 3 molecules of fatty acid. These fatty acids may be same or different. Now, triglycerides, how they have formed the ester bond. So esters of glycerol and fatty acid. So this is actually our starting material for the production of this glycerol and palmitic acid, or this glycerol and 3 molecules of fatty acids. Now, what are those triglycerides? They are forming ester linkage from each hydroxyl group with each fatty acid. So, glycerol madla प्रत्येक hydroxyl group. So, this is the structure of glycerol. So, from glycerol, every hydroxyl group will form a ester bond with individual fatty acid. This fatty acid may be same or different. So during this formation of ester bond कुणाकुणामध्ये फॉर्म होतोय with the hydroxyl functional group of glycerol molecule and carboxylate functional group of acid molecule. So during this formation, carboxylate charge is lost. What will be the charge present on the carboxylate group? Carboxylate group, negative charge. So this negative charge is lost during the formation of ester bond. So these triglycerides are more hydrophobic than fatty acids, as they have lost carboxylate and have formed a ester linkages. Now, This is an general structure of triglyceride molecule. So this is a basic and general structure of triglyceride molecule. So individual hydroxyl group of glycerol molecule form a ester bond with three molecules of fatty acid. So this in this manner they are looking like those triglyceride molecules. Now, so during this formation of this triglyceride molecule in our body, so our body will form this ester linkage with the help of enzyme. That is the formation of ester bond will be taken place in our body with the help of enzyme. Now, what this is a question I am going to ask you. What are the fatty acids in the following triglyceride molecule? Now, tell me, or you are going to uh, text the message in the chat box. What are the names of these fatty acids? First fatty acid, second fatty acid, and third fatty acid. So who is going to give the answer for this question? Anybody? You are going to drop the message in the chat box. Acid number 1, name of acid number 1, second and third. Or later on you are going to take the just screenshot of this and tell me the answer of this question. What are the names of these fatty acids? Okay. Now, properties of triglycerides. Just now we have discussed the reactions of fatty acid yesterday. Now, how there is formation of ester bond taken place, this also we have discussed. Now we are going to discuss the properties of triglycerides. What are triglycerides? Alcohol functional group of glycerol molecule formed ester bond with either same three fatty acids or different type of three fatty acids. This combined molecule is known as triglyceride. Now, what are the properties of that triglyceride? Unsaturated compound secretes, or sorry, unsaturated compound reacts with H2 in the presence of nickel and platinum as a catalyst. So those triglycerides having unsaturated fatty acids, that means presence of carbon-carbon double bond, will be converted into a carbon-carbon single bond. This is a first reaction given by all type of triglycerides. All type means those containing unsaturated fatty acids in their structure. Now upon hydrolysis, the triglyceride molecule already we have discussed are going to form split by the water and forms acid or enzyme catalyst. So after the hydrolysis, they are going to produce glycerol and three molecules of fatty acids. Now, first reaction, that is hydrogenation. So after hydrogenation of triglyceride molecule, the double bonds which are there in the structure of fatty acid of triglyceride are hydrogenated and converted into saturated fatty acid. So hydrogenated converts double bond in the oil to the single bond. The solid products are used to make margarine and other hydrogenated atoms. Again, we have discussed this reaction, that is saponification. But we have discussed this with respect to the fatty acid. But triglyceride molecules also undergo saponification reaction because triglycerides also contain fatty acids. So hydrolysis with strong base, triglyceride split into म्हणजे हायड्रोलिसिस होतं. हायड्रोलाइज झाल्यानंतर काय फॉर्म होतं? ग्लिसरॉल अँड salt of fatty acid. The salt of fatty acid is known as soap. Means individual fatty acid पण soap formation च्या reaction ला जातो आणि triglyceride molecule also undergo formation of soap reaction. So this is a reaction of saponification when fatty acid will react with strong alkali, that is sodium hydroxide. They will first of all hydrolyze, म्हणजे this ester bond first of all hydrolyze. So there is formation of glycerol molecule and a salt of fatty acid. See, acid आणि alkaline एकत्र येत आहेत, that means there is formation of salt. आणि हा salt of fatty acid म्हणजे आपला soap. Okay. Now, characterization of lipid. So these are unique properties of lipid. जसं की आपण प्रत्येक लिक्विडच्या युनिक प्रॉपर्टीज मध्ये कन्सिडर करतो डेन्सिटी, then RF value. So these are characteristic properties of those compounds. So similarly, there are some characteristic properties of lipids are there. And what are those? The first characteristic property of lipid is acid number, saponification number, iodine number. Many more are there. 3 to 4 additional are there, which are also the characteristic properties of lipids. But we are interested in acid number, saponification number, and iodine number. Now, the definitions of these generally or 100% will be asked in your theory exams. They may ask the principle involved in this reaction. They may ask the significance of these characteristic properties of lipids. Now, what are acid number? It is the number of milligrams of potassium hydroxide required to neutralize the free fatty acid present in quantitative amount is there present in 1 gram of fat. So what is acid number? It is actually the amount of, that is milligrams of potassium hydroxide required to neutralize the free fatty acid present in 1 gram of oil or fat. This is our first characteristic property. Second characteristic property is saponification number. What is saponification number? It is the number of milligrams of potassium hydroxide required to completely saponify the formation of soap of how much amount? 100 grams of oil and fat. So this is our second characteristic property. Our third characteristic property is iodine number. Acid number, amount of base required to neutralize. Saponification number, amount of base required to saponify, 100 gram. Here 1 gram. Now what is iodine number? It is the number of grams of iodine that combine with 100 grams of oil and fat. So here there is combination reaction. It is a measure of degree of unsaturation. Means for 100 gram of oil or fat, to determine the degree of unsaturation, that means how many number of double bonds are there in the structure. So to determine this, we have taken 100 grams of oil or fat. So this will determine the degree of unsaturation of fat and oil. A high iodine number indicates high degree of unsaturation. जेवढा iodine number जास्त, it will determine the degree of unsaturation of fatty acid of that fat. Now the principle involved in this particular reaction. So first we will discuss the principle involved in determination of acid value of the compound. So what is the principle? What is the definition? The acid value is the number of milligrams of potassium hydroxide required to neutralize a free fatty acid present in 1 gram of the substance. Here, direct titration is done taking a neutralized mixture of equal volumes of 95% of ether as a solvent and phenolphthalein as an indicator. So, this neutralization is done by this potassium hydroxide in the presence of ethanol and ether as a solvent. So, this is a formation of potassium salt of free fatty acid, that means soap. Now, what is the significance of this? What is the significance of this acid number? As oil and fat undergo rancidity, so they are converted into free fatty acid. And the rancidity means what, that we will discuss after this slide. So this will convert into a free fatty acid and glycerol, which will cause an increasing in the acid number. A similar observation is observed with the biodiesel aging through the analogous oxidation process when they are subjected to the prolonged high temperature and exposure to the acids and bases. Low acid value indicates good cleaning by the flow. So this acid value will determine the purity or quality of that oil sample. जेवढी acid value less, that means the oil is pure and qualitative. If the acid value is more, that means acid value is more, that means it will contain more number of free fatty acids. जेवढे fatty acid जास्त तेवढं त्याला alkaline solution जास्त लागणार to neutralize. So there will be increasing in the value of acid. So that means pure quality or rancid oil it is there. What is the procedure? For that we have taken, this is actually a practical point of view. Just we will read. For that we have taken 10 grams of fatty acid or oil in 50 ml of mixture of equal volumes of ethanol and ether. That means 25 ml ethanol and 25 ml of ether, which are previously neutralized with 0.1 molar potassium hydroxide. If sample does not dissolve in the cold solvent, so we are going to just warm the sample to dissolve, and with the frequent shaking we are titrating this mixture of solvent and acid lipid sample with 0.1 molar potassium hydroxide until the solution remains faint pink color after 30 seconds. So the solution will be produce a faint pink color which will not vanish after 30 seconds. So this will be the end point of the titration. So we are going to note down the burette reading and we are going to take the average of all those burette reading. Now how we are going to calculate the acid value? So acid value is equal to volume of potassium hydroxide required to neutralize free fatty acid multiplied by equivalent factor multiplied by 1000 divided by weight of sample we have taken. Now here we have taken 10 gram of the sample. So that weight of the sample is divided. Now N is the burette reading. The factor for the calculation is 0.0056. multiplied by 1000 divided by W is the weight of sample in grams. So this calculation will give us the value of acid number. More is the acid number, pure poor quality is the sample. Less is the acid number, good quality of the sample. Now our second characteristic property is saponification value. Already we have discussed the definition. Saponification value is defined as milligrams of potassium hydroxide required to saponify 100 gram of fat and oil. So they are going to form the soap. Reaction is same in both the cases. But in acid value, neutralization reaction. In saponification value, soap formation is the reaction. So where we are, this saponification value also, more is the saponification value, poor quality is the sample. Less will be the saponification value, good quality of that oil and fat sample. Now procedure. About 2 gram of the fat and oil we have taken in the conical flask, which will be dissolved in 25 ml of 0.5 normal alcoholic potassium hydroxide solution. Now this mixture is refluxed using water condenser. हे reflux करायला ठेवायचं. Now in next experiment, I will show how the reflux can be attached. So where we are. So this reaction mixture we are going to heat on a butter bath for half an hour. Then we are going to cool the mixture and titrate against 0.5 normal hydrochloric acid using 1 ml of phenolphthalein solution as an indicator. The number of ml of acid. Now in acid value we have titrated with base. Here we are going to titrate it with acid because we have taken potassium hydroxide in the conical flask. Now number of milligrams of acid, burette reading of acid required to neutralize that soap, required to neutralize that alkali, we are going to determine. So same here, for that we are going to take the burette reading, calculation of average burette reading, and what is the formula for saponification value? Volume of acid required to neutralize after neutralizing potassium, after neutralizing free fatty acid. So how much amount of potassium hydroxide is remaining after the neutralization of free fatty acid multiplied by factor, multiplied by 1000 divided by weight of sample in gram. So what is the formula? B minus A. B is the bland solution in which rest of the procedure we are going to do. बाकीची procedure सगळी same करायची. जसं की आपण saponification value ची ही procedure follow करणार आहोत. Same procedure we are going to follow, but in case of bland, we are not going to take the oil sample. So same procedure we are following without taking the sample. आणि या दोन्ही सॅम्पल वरती आपण सेम प्रोसिजर करणार आहोत. वॉट एव्हर वी आर गोइंग टू डू फॉर द ऑइल सॅम्पल, द सेम प्रोसिजर वी आर गोइंग टू डू फॉर द ब्लँक सॅम्पल. ओनली we are not going to take the oil sample. Rest of the procedure is same. So the burette reading produced by without taking sample minus burette reading produced by with sample multiplied by a factor that is 0.02805 multiplied by 1000 divided by W. So this will be the formula for determination of saponification value. So the resulting value give us the saponification number. More is the saponification number, more will be the poor will be the quality of the sample. Less is the saponification number, good quality of the sample. Now, this is a very important phenomenon, give a property, or we can say parameter shown by the fats and oils. And this property or parameter is known as rancidification. Now, what is rancidification? When lipid-rich foods are exposed too long to the oxygen in the air. Lipid containing fruits, मग ते तुमचं ऑइल असू दे, घी असू दे, युअर होममेड घी, they may spoil and become rancid. So they are going, आपण जर ते खूप दिवसांसाठी तसेच ठेवले, they may give a bad odor. The unpleasant taste and smell associated with the rancidity results from the oxidative cleavage of the double bond in the unsaturated fatty acid. So what happens? If that lipid sample contains unsaturated fatty acid, those unsaturated fatty acid will oxidize in the presence of oxygen in the air. त्यांची ऑक्सिजन बरोबर रिॲक्शन होते आणि ते डबल बॉन्ड्स ऑक्सिडाइज होतात. आणि हे ऑक्सिडेशन झाल्यामुळे आपण जर ते ऑइल सॅम्पल we are going to preserve it for prolonged period of time, it will give bad odor and taste, which produces aldehyde. Why it is happening? That double bonds will oxidize and converts into an aldehyde and carboxylic acids of shorter chain length. ते आपण बघितलं का after hydrolysis, after oxidation, the fatty acid is going to form the acids of shorter chain length and therefore high volatility. So deterioration व्हायला सुरुवात होते त्या oil and fats. So this after rancidification of lipid sample, they are going to produce the free fatty acid. That means if the oil and fat sample, if we are going to preserve for prolonged period of time, they are going to produce free fatty acids. And this free fatty acid we are measuring, we are quantifying in the terms of acid number and saponification. म्हणजे जेवढी रॅन्सिडिटी जास्त तेवढी त्या ऑइल आणि फॅटची क्वालिटी कमी होणार. दॅट मीन्स दे आर गोइंग टू गिव हाय ऍसिडिटी व्हॅल्यू अँड हाय saponification. So this is an rancidity of oil. So what we have discussed today? Today we have discussed very important points. We have discussed what are triglycerides, how the formation of triglycerides takes place in our body. Then we have discussed properties of triglycerides, hydrogenation, hydrolysis. Then we have discussed triglycerides also undergo a chemical reaction, that is saponification. After that, we have discussed a unique properties of lipids. Those are acid number, saponification number, and iodine number. Out of that, we have discussed the principal procedure involved in the acid number. Then we have discussed principal procedure involved in the determination of saponification number and what is the phenomenon responsible for formation or deterioration of fats and oil. The phenomenon is known as rancidification. So this we have discussed today in